Welcome to 100 Days of Code with Here. My name is Shruti and we are in week 17 of 100 Days of Code with Here. And while in the last few weeks we discussed about the Fleet Telematics API, this week we are going to go a little further into the Fleet Telematics API and sort of look at a few powerful endpoints of this API. Meanwhile, if you are new to 100 Days of Code with Here, there are links in the description below, which will take you to a blog post that tells you everything about what 100 Days of Code with Here is. If you already are onto this journey and you've missed a few solutions or you just want to take another look at them, you'll also find those links in there. And for the others, there's also a link to the GitHub repository where you can directly sort of clone and start from there. So let's begin with day 81. For day 81, we are going to take a look at one of the hidden gems of the Fleet Telematics API. So let's go to developer.here.com and let's go to the documentation part. And again, let's head directly to our Fleet Telematics APIs. So you have the Fleet Telematics APIs, you have geofencing, custom routes, etc. within them. And what we are interested in is the basic Fleet Telematics API. And when you scroll down on the left, you'll see that you have this electric vehicle routing with charging section. Now, if you go through this article, you'll see that this API is really powerful in the sense that not only does it give you a route from A to B for EVs, but it also gives you all the EV charging stations along the route. And the way it does that is with the normal waypoint, the starting and ending point with the mode and departure date and time. What you need to include in this call is the custom consumption details. Now, the last time we used this was in week 16, and we used the custom consumption details to sort of get the cost associated with the route. This time, we are going to include it so that we can sort of define when we would need a charging station. So, as I said, this routing engine gives you all the EV charging stations along the route. On top of that, you can also ask the routing engine to give you the suggested stopping points to recharge your battery. So when I say that, what I mean is that I can say battery parameters. I can add the battery parameters. So let's say the initial charge in my battery is 15. The maximum charge is, let's say, 33. And then the minimum charge at a stop should be 7, let's say. What all this means is that I'm specifying the level of my battery or the charge of my battery here initially. I can specify what is the maximum charge that my battery holds. And when my charge drops to 7, I want to stop at a EV charging station. So whenever that happens, please suggest me what kind of or where is the stop that I should stop at? Where is the EV charging station? And the way the routing engine decides this is that it has this consumption profile here. So it calculates that, okay, if this is your speed, if this is how you're going along this route, your charge is going to be sort of drained up to level 7 at a certain kilometers. And then it sort of searches for or gives you the nearest EV charging station in that area. So this is a really powerful API which does a lot of things for you here. So I'm going to leave it at that. I'm going to just add the consumption details. I'm going to add the battery parameters. You can sort of take a look at the other parameters that you can add, which is specify which type of connectors that the car supports, or if you want if there's a route that does not have a lot of charging stations, you can also increase the radius where you can find the charging routes, or the detour you would be willing to take to go to a charging station, and so on and so forth. So let us add a few more things into the charging curve. Let's do that. So again, this is some random charging curve that I found out by just doing a search, and you can enter the charging curve that your vehicle or your battery sort of displays. And I'm just changing a few parameters here according to what kind of battery that I had selected. Now on saving this, I should get a response. And within that response, what I get is, so one, I get the shape, which is what I've used to draw this. And then I get a waypoints, which is fine. What I really used here is the waypoint type. Now, if you sort of open this up, expand this further, you'll see that you have the waypoint, longitude, latitude, basically the position, and then you have the type of the waypoint, which this says stop over. And if you check this one, this is charging stopover. So this is a waypoint that you can stop while driving, because it sort of says that you cannot drive continuously for so and so many hours. So this is a normal stopping over waypoint. But this is interesting. This is a charging stopover. So the routing engine has recommended you that you can charge your vehicle here, because the charge in your battery has fallen, or should have fallen, below 7. So in this way, the Fleet Telematics API, and within that the EV charging, a route with EV charging stations, can give you the different waypoints or the different EV charging stations that you can stop along in your route. And that was it for day 81. For day 82, we are going to take a look at a very classic problem, which is also called as the traveling salesperson problem, which is you have, let's say you have 10 packages and you need to do all the deliveries today. And you, let's say, start from the hub of your delivery center. You're here and you have 10 different locations and you need to deliver all the packages in time. Now, for this, traditionally what was done is you have a person, an actual person sitting there and sort of calculating the distances with the routing API, of course, but sort of calculating the distances from the starting point to the different destinations, and making a proper plan wherein you would either save on time or distance, and then someone would put up that chart, and then the delivery person would go and deliver in that particular sequence. So it would take a lot of efforts to do that on a daily basis. Now, the API that we are going to talk about for day 82 solves this exact problem. And this API is called the Waypoint Sequence API. So let's go to developer.here.com and go to the documentation section. And if you scroll down here, you'll see again the Waypoint Sequence API is also a part of the Fleet Telematics series, or the Fleet Telematics APIs. And when you go there, it says exactly that. It solves the traveling salesperson problem. And then you have two options, which is optimized for waypoint sequence and then there is passenger pickup. We'll look at the optimized waypoint sequence for the fastest car route. Now, if you go to this example right here, you'll see that you have a different URL. So let's check this URL first. So this URL is the one that we need to use for our Waypoint Sequence API. I'm going to change that here. So what it says is a Waypoint Sequence API, find sequence.json. You have the API key. Now what you have is a starting point. And a starting point can be given as an address, which it can geocode, or you can just directly give your location in terms of latitude and longitude, which is the geo form of the location, the geo point, so to say. So let's start from Berlin, and this is the center. I think this is the address for the here office in Berlin. Let's make that our hub address. And now you can enter destinations as destination 0, 1, 2, and so on. So I have a few destinations here. I'm going to copy that quickly. Okay, so what I've done is I've entered destination 0, destination 1, destination 2. So I've entered 3 different destinations. And let's see what else. Now, once you have that, you also need to specify your mode of transport. So it's fastest, car, traffic disabled, that's fine. And then you get to this important part where it says, also you can also specify the end of your route. If you want to end at a specific place, let's say you want to end again at the beginning, you can also do that. But I'm not going to mention the end point here because they can end the journey wherever they want. Now, if you go to the API reference section, you'll see all the parameters that can go into this. So you have the departure, you have the destinations, and you'll see you can have, let's see what this says. So intermediate destinations, if at least one, if no, the end parameter is provided. And it says that the maximum number of waypoints, including the starting point and the ending point, is 120 without traffic and 50 with traffic. So that's a lot of intermediate destinations that you can use for finding a sequence. Then what I'm interested here is the improve for, the parameter called improve for. So when you say you want to optimize your sequence, you are optimizing it for something, right? Either you're optimizing it to save time or you're optimizing it to save distance. So either ways, whichever one you want. For this, we're going to select time. And now if I save this, I should get different routes, and I'll explain you the result that we get through this. So you get an array, and this array has interconnections, and it says from waypoint, so start, to waypoint destination 2. Now it says that the first leg of interconnection is from the start point, so this one, to destination 2. So basically the routing engine has figured out that if you start from here and go here first, this will be a good start to save time. Then you need to go from destination 2 to destination 1, and then from destination 1 to destination 0. So what it has done is it has given you a sequence which is the most preferable to follow. So what I've done is I've just listed down what was what was the original sequence that we entered and what is the sequence given by the routing engine. So start was, I had given this a start, it is sequence 0. This was destination 2, but this has been made the destination sequence 1, and so on and so forth. So this was the Waypoint Sequencing API, which improved for time. With day 83, we are going to take a look at another interesting API within the Fleet Telematics realm. And this one is called the Custom Routes API. Now, this is interesting because we've taken a look at custom locations, we've taken a look at geofencing, where we did sort of an uploading a layer and then we used the layer in our application. And this is on the same lines as that. When in custom locations and in the geofencing, when you uploaded layers or locations, in this you are able to upload a complete route. On the other hand, you are also allowed to sort of change the parameters or properties of existing routes. So imagine you have a logistics business and you want to transport, let's say, some goods to the nearest IKEA, and let's say you are an IKEA vendor. You are not going there to buy something from IKEA, but you supply something to IKEA. And you want a route from your location to IKEA. So let's do that. And I want to go to IKEA Schöneberg. And I'm going to say my location. And now if I see this, my truck can go, let's zoom into it a little bit. So my truck can go into this parking space. This is sort of a parking space, and then I have to unload the material that I have, and then let's say the docking station of IKEA is here. This is where the material is unloaded. So if I take this here, let's say I want to go here instead, not the IKEA place. You can still see that you're not able to go here. This is the nearest place you can go through the route. And now what I want is, I want my truck to directly go to this route. Now I know that there is a road which exists here. This is not open for vehicles. And so what I'm going to do is add a custom route from here to here so that my truck or my car or whatever is able to go directly from here to directly unload the consignment. So let's get on with it. Also, like I said, if there was an internal route which is not allowed for trucks or any of the vehicles, you could also set that to allowed. You can avoid certain roads in a similar manner, and you can also allow and sort of restrict vehicle types on certain roads. So what we're going to do is create a route. So let's do that. What we're going to do is go to the guide section, as always. Check the URL. Now we're going to use the new URL, which is the Fleet API. So let me clear this up. Let's first get this. I'm going to sort of do a drawing of the route first. This is the origin. This is the IKEA that we wanted to go to, or this is the place that we wanted to go to. And I'm going to draw this out. Once we draw this out, you'll see that the road sort of stops here. And what I want is a route from here to here. So I'm going to click on the points to sort of roughly draw this point out. So draw this road out. And the reason I'm putting these pointer is that if you've followed the earlier days of code, you'll remember that I had written a small function wherein I could sort of point anywhere on the map, get a marker there, and in my console, I could get the position. So wherever I place the marker, I got the position, and I've just collected the lat and long. So now what I'm going to do is I'm going to just draw this lat and long on top of my route. So let's just first draw this. Okay, this is the same lat and longs I've collected. I've collected fewer lat and longs, that's fine. Now if you zoom into here, I should have zoomed in with my application, but that's okay. So if you zoom in here, what you'll see is this is just a line I've drawn from here until the supposed docking station that I said, right? So this is the docking station, and now I want to upload this route onto my layer. So let's get on with it. I'm going to call it upload custom route, and let's change this to upload custom route. Okay, I'm going to change the fetch part to just get a console like response, just logging out the response. So let's get rid of all this, and you fetch the URL, you just get a response. Okay, and now we need the URL and the parameters here. So when you go here, when you go to the guide section, you have a construct request. You'll see that you have the fleet.ls.yourapi.com, and then I'm using the new URL. So then you have /2, and then you have overlays upload.json. So I'm going to change that. So this is to upload the overlay. Now you can click on this example to go further into the overlays parameters. And there you see. So you have to have something called a map name. That is the first and foremost thing you see in the description. So what this means is that whatever you're going to add onto this map, it will be added in the form of a map layer or a different, completely new map, so to say. And so this needs to have a name, and all the map layer names or map names should start with overlay, and then you can follow it up with whatever you want. So I'm going to call it IKEA Road. Let's call it that. And you'll need to remember this name, because when you say you want to route through this layer, you have to remember this name and tell the routing engine to route through this layer as well. So let's do that. Now, after the map name, you need something called an overlay spec. And in this overlay spec, I am going to define the route that we just created. So if you click on this overlay description format, you'll see that it has sort of 3 sections. One is the OP, so operation, and then the operation you want to do is create. So let me fill that out. Right? And then when you want to create objects, you can create shapes, layers, you can create shapes, and in that what we've created is the line, so polyline. So then I'm going to write shape into this, and then I'm going to upload my my layer, so these points that I sort of collected, as my shape. So I'm going to basically define it as an array of points. I am going to copy it here, but the format is with, let me just change this. The format is that you need to have square brackets, and you cannot have the lat long. So let's change that quickly. So this is your shape. This is the format of the shape that you're going to define. Basically, you've said that, hey, my layer has a shape which is an array of points, and then you will have to define the data. So what is the data you want to send with this layer? So I want to send, let's say, a road name, and I want to define the travel direction of this layer. So if you see this, currently this supports travel direction and vehicle type. So I'm going to define the travel direction, and then I can say the travel direction is bidirectional. I want the road to be bidirectional because my truck needs to go out as well. So that with that, I have defined the overlay specs. And now what I want to do is mention that this is a read-only storage. So let's get rid of all of this and storage read-only. Now, if you want to know where I got this from, if you go back, you'll see that the storage parameter is mandatory and read-only is currently the only one supported. So I've added storage read-only. And now if I save this, I should get, hey, you've created. Oh, okay. What we've missed here is adding a plus sign. Okay, now if you send this, you should definitely get, hey, you've created a layer. So let's see that. So as mentioned, you've received a response code which says 201 layer created. And if you go into the details, you will see that the points that you've added have affected all these 3 layers. What you've done is you've basically uploaded a layer, a custom layer, which is going to be considered when you want to route your vehicles along this route. And again, this is tightly bound with your API key. So someone else with another API key cannot use this road. So that was it for day 83. With day 84, we are going to learn to actually draw or get a route using this layer that we created in day 83, and then get a route for your truck, your car, or whatever through this area or through this route. So let's go to the documentation and see what it says. And so we've uploaded an overlay map. Now let's go to calculate route. So basically this looks like a normal calculate route. You have calculate route.json, you have the API key, you have the mode, you have a waypoint 0, waypoint 1, blah, blah, blah. And then what is important is this parameter here. So this says, with this, what we can do is we can mention that what overlays do you want me to consider while creating a route for this map. So this is where you will input your old, the old name, the overlay name. And so the overlay name was overlay IKEA road, if I remember right. And now if you press save, you should get a route through this overlay layer. And so what has happened is that from here, your truck can take the route to this docking station. And in the background, you can see the red one was the overlay that we drew. And then it has linked to the main road, the normal road, through this. So that is how we've uploaded a custom layer and then gotten a route with that custom layer. Again, remembering this name of the overlay is important while getting the routes. And then on the other hand, you can use these to list out and do other things with your routes. You can also list out your routes or your layers using, let me see, what was that? Using list, overlay list, and overlay delete. So you can also delete and list the overlays. On the other hand, if you want to see your uploaded layers, you can go to enterprise.here.com and enter your app ID and API key. And you can also see the layers in there. I'm not going to do that yet, but you can go to enterprise.here.com, log in with your app ID and API key, and then you'll see your layers. So that was it for day 84. with day 85, we are sort of going to dip our toes into this another giant API that we have, and it is called the Advanced Datasets API. Now, what we were supposed to do for day 85 was use the advanced dataset called EV charging POI and display all the EV charging stations along the route from day 81. So before that, I'm going to explain what advanced data sets is all about. So let's go to the, let's go to the rest. We have more explanation here. Now, the advanced dataset API or the Fleet Telematics advanced data sets are basically layers of data, which is it could be give me the census data for this whole layer. It could be, hey, give me all the EV charging points in this district. And so when you do a normal search, you have this limit of 100 POIs that you can get in return. And sometimes you don't want just 100 points of interest or locations. What you want is everything. You want everything that there is in that district, in that city, or in whatever your requirement is. And that is when this huge advanced dataset API will be put to use. So what this does is every layer that there is, so the data has been sort of arranged in the form of layers, and it has indexes, it has attributes. So just take a look at the guide section and key concepts of what data layers are or advanced data sets are, and just go through this. And what I'm going to show you is that basically you have a list of layers. So currently you have these list of layers, which is you get sort of administrative geometry of this area, or you can get the cartographic polygon, you can get the census data, you can get city center POI information, you can get distance markers, you can get EV charging stations, fuel stations, etc. And this is a bigger data set because you can sort of ask the engine to give you all the EV charging points along a certain area. And the way that this area is defined is in the form of levels and map tiles. So what it says is, again, feel free to read the description here, but what it says is at a certain zoom level, if you have the map at a certain zoom level, and if you can span it from tile Y to tile X, so a certain area at that zoom level, we have all the information about this area there. So again, this may sound confusing, but let's take a look at one of them. So if you want to find out what all layers are currently available, you can make this call, which is s.fleet.ls.yourapi.com/doc/layers.json. It will list all the available layers. And now when you list these layers, it also gives you the tile level at which these layers are available, and also the tile X and tile Y maximum values where these layers are available. So it should look something like this. So if you look for a specific layer, it will show you what attributes does the layer contain, and then what is the layer's extent, where is it available. So again, this is extra information. We don't need this for this particular use case. What we need is, we already have the name of the API that we're going to use, and or the layer that we're going to use, and that is called the EV charging POI. Now, I've already found out what the layer or the zoom level is for this layer. I've already found out what the tile X and tile Y is, and what I'm going to do is, instead of listing the EV charging points along the whole district or along the whole area, what I'm going to do is display the EV charging points along a corridor and along a route. And for this, I'm going to use the along a corridor attribute of this. So let's take a look at corridor search. So what we're going to do is use the corridor search on getting the corridor. We write the API key, we write the layer ID, and then we ask for the attributes we want. So again, I'm going to start by just getting the route. So just simply fetching the route, right? And this was route from day 81. So let's clear this up. So this is the route we were talking about. So this was a route from my house to the here Berlin. And what was expected was to get all the EV charging stations along this route. Now, to pass this route as a corridor, what I'm going to do is create or take the route shape. So I think I've logged the route shape somewhere. So we have the route shape as route in the route.shape object, or let's just log this out. So what I'm going to do is within the route, you have this object called shape, and this shape is basically the array of latitude and longitude along that route. What I'm going to do is I'm going to pass this shape as an input to the corridor, because as we saw the corridor search API, yikes, here we go. So the corridor search API has this parameter called corridor parameter. You can sort of use coordinates of this polyline that we get in the route. So I can directly pass that. So I'm going to pass this into the search corridor, the route shape as a search corridor. And then let's write the function for getting the search corridor. Just stay with me here. So what I've done in the search corridor is that I've used the search URL as fleet.ls.yourapi.com/1/search-corridor.json. Now let's go back a little and check the URLs. So it says the path is fleet.ls.yourapi.com. We have that. Then it is /1. Okay, we have an extra forward slash here. And then you have search/corridor. Okay. Now, when you click on the search/corridor, you'll see that example again. So then we have the API key. Fair enough. In the corridor, we have taken the route shape directly. So I've added that as the corridor. Now there is a parameter called radius. Now the radius is how far do you want to divert from the route, or the buffer radius of the route, where you can still go take a detour and go for that EV charging station. So I don't want to go too far away. I'm saying that 500 meters is more than enough. Then in the layer IDs, I'm going to mention the EV charging POI that we sort of noted down. And then in the key attributes, so this is what do you want to see from the layers. So the layer is EV charging point or points of interest, and within that they have a lot of attributes. So what are the attributes you want to retrieve? Because you don't want to retrieve all attributes, because that would be a lot of data to handle. So with key attributes, you can define the specific attributes that you want to get from this layer. So with that, I am going to mention the POI IDs. I just need the IDs, and you'll already get the latitude and longitude from them. And then I'm going to handle the result by just displaying this. So let's write that. So once you do this, what you're getting is geometries, and these are all the EV charging stations along this route. Now what you get with them is you get the attributes, which is category ID or POI ID. Then you get the connected type of this. You see what fuel is available. You have the link ID, you have the name, if it is open, payment, side of the street, private access, POI ID. That is what we specifically wanted. And then distance from the route. and then the nearest lat and long to access this. So you'll get this information for all the different POIs or all the different EV charging stations that we received along this route. Now I'm going to write a small script to just display these. And this is nothing but I'm just taking, sort of parsing the locations from here. What I've picked up is the nearest lat and nearest long. And I have just put a fancy marker here, and there you go. You have all the EV charging stations along the route. And now you can sort of change the radius to sort of get more or fewer charging stations. So let's just check that. If I make this 100, I should possibly get fewer EV charging stations. So there you go. Then this was it for day 85, and this was also it for week 17 of 100 days of code with here. And so this week we've sort of taken on a lot. We've looked at the Waypoint Sequencing API, the EV routing option, the custom routes, and advanced data sets. Now this was just the tip of the iceberg. This was just a very small part of these APIs. So I would definitely encourage you to go down to these APIs to take a look at the documentation and take a look at all the use cases that you can use these APIs. And so also we already have these code snippets in our GitHub. So go take a look at that and keep following 100 Days of Code. Happy coding.